Okay, we will look at the derivative of the inverse functions. Okay, and so here before that, let's recall what are the inverse functions. So we have a function f, right, x, and we denote its inverse function by f inverse. Okay, sorry, f inverse. Okay, so here is the definition of the inverse functions. If these two functions are inverse functions, then f, the composite function f of f inverse would be x, right? And f inverse of f of x is also x. Okay, so here is some conventions for the notations. So f inverse is not 1 over f of x. Okay, so what is 1 over f of x? 1 over f of x, if you want to write as a power, it should be f of x, then we put the bracket, then raised to the power negative 1. So that is the negative 1 power. Okay, so we start from the f of f inverse of x equals x. Let's take the derivative on both sides about x, okay? So let's take the derivative on both sides of this equation. Right? Then the right side, the derivative of x about x, which is equal to 1, right? The left side, which is the derivative of a composite function, right? So we can use what? We can use the chain rule. The chain rule is f, take the outside function is f, right? So take the derivative about f, then plug in f inverse, multiply by the derivative of the inside function. Inside function is f inverse, right? The derivative of inside function. So then we have the f inverse of x, take the derivative. In other words, the derivative of f inverse would be equal to 1 over f, the derivative of f, then evaluate or plug in f inverse. Okay, so this is the formula for the derivative of inverse functions. So now let's look at some inverse function, some derivatives, some formulas, okay, for the inverse trig functions. So the derivative of inverse trig functions. Okay, so I just give you the formula, okay? So we don't want to derive it. I just give you the formula here. You will use in future. So the sine inverse of x, we take the derivative. So we also know sine inverse can be written as arcsine. Take the derivative, it's equal to 1 over square root 1 minus x squared. Okay, so how to derive this formula? We can use this formula, the derivative of inverse function. Okay. The next one, cosine inverse, the derivative is equal to, cosine can be written as arc cosine x. Take the derivative, it's equal to negative 1 over square root 1 minus x squared. Tangent inverse. So this is not a negative 1 power, okay? It represents the inverse function, which is the derivative of arc tangent x. Take the derivative, is equal to 1 over 1 plus x squared. Then we have cotangent inverse or arc cotangent. Take the derivative, is equal to negative 1 over 1 plus x squared. And arc sine inverse, sorry, not sine, arc secant or secant inverse or arc secant, which is equal to 1 over the absolute value of x times x square root x squared minus 1. So the cosecant inverse, which is arc cosecant, take the derivative, is equal to negative 1 over absolute value of x times square root x squared minus 1. So here you should know the first three. You should be very familiar with the first three formulas. So now let's look at some examples. Okay, so we have, we want to look at the derivative of arc sine of 2x. Okay. So arc sine of x, which is equal to 1 over square root 1 minus x squared, right? But arc sine 2x, take the derivative, it's not just equal to 1 over square root 1 minus x squared. It's actually the composite function, right? This is the composite function, and the arc sine composed with 2x. Okay, so this is the composite function. The outside function would be the arc sine. Okay, so we can use the chain rule, right? So the inside function is 2x. So the chain rule says it should be the derivative of arc sine. So the derivative of arc sine is this one, right? 1 over square root 1 minus, so here is x squared, but because here is x, right? But here is 2x, so we have 2x squared, not x squared. Okay. So this is the inside function. We plug in the inside function, then times the derivative of the inside function. So that is the chain rule. So then you can simplify, it's equal to, this is 2, so it's 2 on the top, square root 1 minus 4x squared. Okay, so now similarly, let's look at the arc tangent of 3x. Take the derivative. So again, the outside function is arc tangent. The inside function is 3x, right? So the derivative of arc tangent, or the tangent inverse, is 1 over 1 plus something squared, right? But here's x, so here's x squared. So, but here is not x, here is 3x, so it's 1 over 1 plus something squared. What we should plug in? We should plug in the inside function 3x squared. Then multiply by the derivative of the inside function. So you don't forget this step. Okay, then you have this is 3 over 1 plus 9x squared. Okay, so now let's look at another one. What is the derivative of arc cosine e to the 2x? Okay, so the outside function again is arc cosine. The inside function is e to the 2x, right? So arc cosine, so the derivative, so it would be the derivative of outside function, then plug in the inside function, right? The derivative outside function, the arc cosine is -1 over 1 square root 1 minus x squared. So here is x, here is x squared. So here should be e to the 2x. So this would be -1 over square root 1 minus something square. So what we should plug in here? Here is not x, here is e to the 2x. So we plug in e to the 2x, right? Then square. But we cannot stop here because we need to multiply it by the derivative of the e to the 2x. Okay, so now let's continue. This is -1 over square root 1 minus, let's square out, this would be e to the 4x, right? Multiply by this one. This is not e to the x, right? E to the x, you can get the derivative directly by the basic rules. But here is e2x. So this is the one, again, this is the composite function again. So we have to use the chain rule again. Okay, so here you can see that the outside function is the e function, right? The derivative of outside function would be e to the 2x, right? E to the something, we should recover the same one, but since it's not just x, it's 2x, so we need to multiply by the derivative of e to x. So this would be -2 times e to the 2x, we put on the top, square root 1 minus e to the 4x.